So, let's go. Number 1, the ANITA Anomaly. Picture a balloon the size of a stadium floating 23 miles over the Antarctic ice, so high the sky above it is already black. Hanging under it is a cluster of radio antennas with one job: listen for the faint crackle a ghost particle makes when it slams into the ice. For years, it works exactly the way it's supposed to. Signals come down from the sky, bounce off the ice, and flip. Like your reflection in a mirror, left turns into right. That flip is how you know a signal came from above. Then, twice the balloon hears something that didn't flip. The signal came up, out of the ice, from the direction of solid planet. You have to understand what that means. For that radio pulse to reach the antenna the way it did, a particle had to punch straight up through the entire body of the Earth, thousands of miles of rock, and come out the bottom of the world carrying the energy of a hard-served tennis ball crammed into something smaller than an atom. Nothing we know does that. A neutrino, the one particle that drifts through planets like their fog, would have been swallowed long before it crossed that much rock at that energy. The Earth is supposed to be a wall. Something treated it like a door. And here's where it gets worse. If real exotic particles were raining up through the planet, other detectors buried in that same ice, watching that same sky, should have caught the fallout. They saw nothing. In 2025, a giant observatory down in Argentina combed through 14 years of its own data hunting for anything that matched. It came up almost empty, which doesn't rescue the boring explanation, it kills that one too. So now you've got a signal that shouldn't exist, and no comfortable answer left standing. It isn't aliens. It isn't a parallel universe, whatever the headlines told you. It's something quieter and stranger than that. One of the most sensitive machines humans ever built, floating over the emptiest place on Earth, caught two things coming from the wrong direction, and after nearly a decade, the smartest people in the field still can't tell you what they were. They can only tell you where they came from. Straight up, through the planet under your feet. Number 2, the boat. It stands for brightest of all time, and for once, the nickname is just the plain truth. On October 9th, 2022, a massive star in a faraway galaxy ran out of fuel and collapsed, and for a few seconds it became the single brightest explosion humanity has ever recorded. Not the brightest that year, the brightest ever seen. Astronomers ran the odds and figured a blast like this reaches us maybe once every 10,000 years. Here's the part that should put a chill in the back of your neck. It happened 2.5 billion light years away. That's so far that the light left before there were animals crawling on Earth. And it still reached across all of that distance and physically smacked our planet's atmosphere. Instruments watch the upper air on the daylight side of Earth get ionized, chemically rattled by a star that died before the first fish. It's the strongest hit of its kind we've ever measured from one of these bursts. Then the observatories in China looked at the highest energy light that arrived, and the real trouble started. Some of those photons carried something like 18 trillion electron volts of energy each, and photons that violent, crossing 2.5 billion light years of space, are supposed to get absorbed on the way, collide with the faint background glow of the universe, and never make it here. They made it here anyway. Enough of them that physicists started publishing papers with titles that basically ask, out loud, whether our rules about light are broken. Sit with the scale for a second. In roughly 10 seconds, this thing let go of more energy than the sun will put out in its entire life. 10 billion years of sunshine in the time it takes to read this sentence. And the jet of it was aimed almost straight down the line at us. We didn't watch this explosion from the side. We looked into the barrel. If it had gone off a few thousand light years away instead of a few billion, pointed the same way, it could have peeled part of the ozone off the sky. It didn't. This time. But it fired once already, and we still can't fully explain the light it sent us. Number 3, the flyby anomaly. Forget deep space for a second. This one happens right here in our own backyard to machines we built with our own hands. When you want to throw a probe out to the outer solar system, you can't just point it and burn fuel. You'd never carry enough. So instead, you swing it past a planet and let that planet's gravity fling it faster, like a kid whipped around by the arms on a merry-go-round. It's called a gravity assist, and the math behind it is more than a century old and precise to a degree that's almost rude. We know exactly how much speed the planet should hand back, down to a hair. Except sometimes, when our probes swing past Earth, they come out the far side going the wrong speed. Not by much. In 1990, the Galileo spacecraft rounded Earth and left carrying about 4 extra millimeters per second that nobody put there. In 1998, a probe called NEAR came around and picked up roughly 13 millimeters per second of speed that simply should not exist. The biggest, cleanest version of the glitch. Rosetta did it too, a smaller bump, back in 2005. Millimeters per second. That's slower than a snail, you'd never feel it. But here's the thing. We track these spacecraft by bouncing radio signals off them across the whole solar system, and that tracking is so absurdly precise that a few millimeters per second is a scream, not a whisper. It's not a rounding error. It's a number that shouldn't be there, sitting right there. So people did what people do. They checked everything. The pull of the tides, the faint drag of the upper atmosphere, the corrections from Einstein's relativity, the push of sunlight, the solar wind, the exact bulge of the Earth. One by one, every ordinary answer got crossed off the list. A scientist at NASA even wrote down a little formula that predicts the size of the kick. From the angle the probe comes in and leaves at, and it fits the data. But nobody can tell you why it fits. It's a pattern with no engine behind it. And then, to make it stranger, some later flybys showed no anomaly at all. As if the universe only does this when it feels like it. We can fling a robot 4 billion miles and land it on a comet. But we can't always tell you how fast it's going after it waves goodbye to home. Number 4. Planet 9. Way out past Neptune, past Pluto, in the dark where the sun is nothing but the brightest star in the sky, there's a graveyard of icy worlds, leftover rubble from when the solar system was born. And a handful of them are doing something they shouldn't. Their orbits are lined up. Picture a crowd of runners on a giant track all sprinting in their own random lanes. And then you notice a whole cluster of them are leaning the same way, bunched into the same corner, as if something you can't see is hurting them. That's what these distant objects are doing. Their long, stretched orbits all tilt and point in roughly the same direction. Random chance doesn't do that. Gravity does. Something with a lot of gravity. So in 2016, 2 astronomers at Caltech did the math on what it would take to keep those worlds in line, and out fell a prediction. A hidden planet, somewhere between 5 and 10 times the mass of Earth, creeping around the sun so far out that a single one of its years lasts longer than all of recorded human history. 20,000 of our years for one lap. Later work trimmed the estimate down to maybe 4 times Earth's mass. Still big. A real planet, not a stray rock. And we have never seen it. Think about how strange that is. There may be a world several times heavier than Earth, a member of our own family, circling our own sun, and it's so far out and so faint that decades of searching haven't caught it. Out there, sunlight is 10,000 times dimmer than the sunlight on Neptune. The planet, if it's real, is a black shape against a black sky. In 2025, someone dug through old infrared surveys and turned up a candidate, a slow-moving dot that could be a giant hiding in the dark. But its orbit was tilted all wrong, way off what the theory wants, and the very astronomer who predicted Planet 9 looked at it and basically said, "That's not my planet." Maybe it's something, just not this. A new telescope in Chile is about to start scanning the whole southern sky over and over, and the people hunting Planet 9 give it a real chance, if the thing is out there, of finally dragging it into the light. Or of proving there was never anything there, and those orbits lined up for a reason we haven't thought of yet. Either answer is a little frightening. Number 5, the 22-minute pulse. Somewhere in the plane of our galaxy, about 15,000 light-years away, something switches on, screams in radio waves for a couple of minutes, and goes quiet. Then, 22 minutes later, it does it again. And again. Perfectly on time. Like a lighthouse. Like a heartbeat. Like a machine. It's called a long-period radio-transient, and when a team in Australia found it a few years back, they had a problem, because objects like this are not supposed to be able to do that. Here's why. The thing pulsing is almost certainly a dead star, a neutron star, the crushed core left behind when a big star explodes. These things normally spin blindingly fast, whipping around dozens or hundreds of times a second, and that furious spin is what powers their radio beam. As they age, they slow down, and there's a line, physicists actually call it the death line, where a neutron star spins too slow to make radio waves at all. It goes dark, it's finished. This one is turning once every 22 minutes. It is so far past the death line, it's almost a joke. By every rule we've got, it should be silent. It is not silent. It is broadcasting, cleanly, on a schedule you could set a clock to. And then they checked the archives, old recordings from other telescopes going back decades. It was already there. It shows up in data from 1988, which means this thing has been sending out its pulse every 22 minutes for at least 33 years. It was doing it when you were born. It was doing it while you grew up. It's almost certainly doing it right now as you sit here. A dead star that never got the message that it's supposed to be quiet. Nobody knows what keeps it going. Maybe it's a magnetar, a neutron star with a magnetic field so violent it warps the physics around it. Maybe it's some strange kind of dead white star instead. They pointed optical telescopes at it, trying to get a proper look, and found nothing where it should be. Just the signal, ticking down out of an empty patch of sky. A corpse that keeps a schedule. For 33 years, it's been calling out, and we still don't know what's holding the phone. Number 6. The Shadow at Cosmic Dawn. Now I have to be honest with you, because from here, the ground gets softer. Everything up to this point, we're pretty sure we actually measured. The next couple of anomalies are stranger than that, because we can't even agree they're real. And somehow, that's the scarier kind. Start here. A small radio antenna sitting out in the Australian desert, something that honestly looks like a metal coffee table, went hunting for the oldest signal in existence, the faint radio whisper of the very first stars turning on, about 180 million years after the Big Bang. Before galaxies, before planets, the moment the universe first caught fire. In 2018, it found something. When those first stars lit up, their light should have made the hydrogen gas around them cast a shadow, swallow a little of the background radio glow. The antenna saw that shadow, which would already have been the earliest thing anyone had ever detected. A miracle on its own. Except the shadow was twice as deep as it was allowed to be. For hydrogen to soak up that much, the gas had to be far colder than anything the standard story of the universe permits. And there are only a couple of ways to chill matter that hard in the newborn cosmos. One of them is that something invisible was touching it. That dark matter, the unseen stuff that makes up most of the universe's weight, was quietly dragging heat out of ordinary matter in the dark. If that's what happened, this little metal table caught dark matter reaching out and cooling the first gas that ever existed. That's the disturbing version. Here's the more disturbing one. It might not be real. A second experiment, built specifically to check the first, went looking for the exact same signal, and didn't find it. It says the shadow, at least the way the first team described it, probably isn't there, and it's confident enough to put a hard number on that doubt. So now you've got two careful teams, two careful machines, both staring at the birth of the universe and flatly disagreeing about what's written there. One of them is wrong. We don't know which. And that's the real horror of this half of the list. It's not that the universe is doing something impossible. It's that we've reached the edge of what we can measure, and out here, our best instruments start whispering different answers about the very same sky. It only gets worse from here. Number 7. The Neutron Lifetime Puzzle. Zoom all the way down now. Past planets, past stars, down to a single particle. The neutron, one of the little bricks sitting inside every atom in your body. Locked inside an atom, a neutron lives basically forever. But pull one out, set it loose on its own, and it falls apart in about 15 minutes, breaking into a few smaller pieces. Simple. We've known that for ages. So here's a question that sounds like it should have one clean answer. Exactly how long does a free neutron live? There are two ways to measure it, and they don't agree. The first way, you take a bottle, a trap, fill it with slow neutrons, wait a while, then count how many are still in there. Do that, and you get about 878 seconds. The second way, you fire a beam of neutrons and count the little wreckage particles they leave as they decay along the way. Do that, and you get about 888 seconds, 10 seconds apart. That doesn't sound like a crisis. It absolutely is one. Because both experiments have been sharpened for decades, both know their own errors down to a fraction of a second, and 10 seconds is far, far more than either of them should ever be off. This isn't sloppiness. Two rock-solid methods of timing the exact same particle come back with two different lifespans, and the gap will not close. Now follow the scary thread. The beam method only counts a neutron by catching the proton it leaves behind when it decays the normal way. So if the beam count comes up short, if it says fewer neutrons died than the bottle insists, then some neutrons in that beam are dying without leaving a proton. They're decaying into something else, something the detector can't see. Some physicists took that seriously enough to say it out loud. Maybe about 1% of the time, a neutron doesn't fall apart into the stuff we know. Maybe it slips sideways into dark matter, the invisible material we've been chasing for a century, right there on the lab bench. Nobody's proven it. In 2025, the people who run every neutron experiment on Earth sat down together to try to kill the discrepancy for good. They couldn't. Not yet. A single particle. The most basic clock in nature, and it won't tell us the same time twice. Number 8, the hole we live in. Everything on this list so far has been something out there. A signal, a star, a particle you could at least point at. This one you can't point at, because you're inside it. When astronomers count up the galaxies around us and not the handful nearby, but the whole sprawl out to about 1 billion light years in every direction, they keep landing on a number that's too low. There aren't enough galaxies. Our whole corner of the universe, a bubble, 1 billion light years across, looks to be around 20% emptier than the universe is on average. We appear to be sitting near the middle of an enormous hole. They named it after the 3 astronomers who first mapped it, but you can just call it the local void, or the local hole, which is somehow worse. And 1 billion light years of below average nothing turns out to be a strange place to live, in a way that actually tangles up our biggest questions. Here's how. If we really are inside a giant underdense bubble, then all the matter packed into the denser walls around us is very gently pulling everything in our neighborhood outward, toward the edges. And that slow outward drift would make the universe look, from our seat, like it's expanding a little faster than it truly is, puffing the number up by something like 11%. That matters because right now, cosmology is stuck in a real crisis. Our different measurements of how fast the universe is expanding flatly disagree with each other, and nobody can reconcile them. And one proposed escape hatch is exactly this, and that we're not seeing the true universe, we're seeing the view from inside a hole, and the hole is lying to us about the numbers. Nobody's certain the void is even as deep as the counts suggest. Some surveys see less emptiness than others, it's still being argued over, but look at what's on the table here. Not a weird object, not a distant explosion. The possibility that the entire sky you've ever known, the normal universe in every astronomy textbook, is really the view out of an unusually empty room. That the ground under your feet isn't a typical patch of the cosmos at all. You grew up thinking your address in the universe was ordinary. It might be a clearing in the dark that shouldn't exist. Number 9, the missing lithium. Go all the way back to the beginning. The first 3 minutes after the Big Bang, when the whole universe was a fireball hot enough to fuse the very first atoms straight out of raw particles. We understand this part shockingly well. We can run the physics of those 3 minutes forward and predict exactly how much hydrogen the young universe made and how much helium. Then we go find the oldest, most untouched matter in the sky and check, and the predictions land at hydrogen, perfect. Helium, perfect. And then there's lithium. Lithium is the third lightest element made in tiny amounts in that same opening fireball, same physics, same 3 minutes, the same equations that just got hydrogen and helium dead, right, run them, and they tell you how much lithium the newborn universe should be holding. Then you go measure the real thing. You look at the most ancient stars we can find, the ones that formed out of nearly pristine early material, and have been quietly cradling it ever since. There's 3 times too little. 2/3 of the lithium the Big Bang was supposed to make is simply gone. Let that sink in. The same recipe that describes the first moment of everything, the recipe we trust so completely because it nails the other ingredients exactly, is wrong about one line. And it's off by a factor of 3. Not a rounding error. A whole slice of creation that the math promised and the universe never handed over. So where did it go? There are 2 ways out, and neither one sits easy. Maybe the ancient stars themselves quietly destroyed their own lithium over billions of years, dragging it down into their hot interiors where it burned away. The trouble is, that would have to happen at just the right gentle rate in star after star, so evenly that they all ended up on the same low number. And that kind of tidy coincidence makes physicists deeply nervous. Or maybe the recipe really is broken. Maybe something happened in those first 3 minutes that we don't understand. Some strange particle, some extra ingredient in the fireball that ate the lithium. But every time someone tries to fix the lithium that way, they break the hydrogen and helium that worked so beautifully. So it just sits there. The universe's birth certificate in ink we've read 1,000 times with one number on it that has never added up. Number 10, the faint young sun paradox. Here's the last one, and it's the one that's actually about you. Think about the sun. Warm, steady, dependable. It hasn't always been like that. Stars brighten as they age, slowly working through their fuel, and we understand that process well enough to run the sun backward in time. When you do, you find that 4 billion years ago, when the Earth was young, the sun was only about 70% as bright as it is today. Do the math on that, and it reads like a death sentence. A sun that dim, shining on the early Earth, should have left the whole planet frozen solid. A white ball of ice from pole to pole, oceans locked hard as rock, for its first couple of billion years. No liquid water, no warm little ponds, nowhere for anything to start. Except that's not what happened. We can read the rocks. There are crystals older than 4 billion years whose chemistry only forms in liquid water. There are lava formations that only take their shape when molten rock erupts into a sea. The early Earth wasn't a frozen ball. It had open oceans. It had the warm, wet chemistry that life eventually crawled out of. The evidence is overwhelming, and it flatly contradicts the sun that the physics demands. Back in the 1970s, Carl Sagan pointed straight at this contradiction, and here's the uncomfortable part. More than 50 years later, we still haven't truly closed it. The best guess is that the early air was thick with greenhouse gases, carbon dioxide, methane, trapping enough heat to beat the dim sun. But when we check the ancient soils for how much of those gases were really there, the numbers don't cleanly add up. The blanket we need doesn't quite match the blanket the rocks remember. So the honest position, right now, is this. For the first 2 billion years of its life, the sun was too weak to keep the Earth from freezing. And the Earth didn't freeze. And the chemistry that eventually became cells, and fish, and dinosaurs, and your own beating heart, got started in water that, by the numbers, should have been ice. You are sitting at the end of a long chain of accidents that begins with a planet which stayed warm when it had no business staying warm. And we still can't tell you why. That's the thread running under all 10 of these. Not that space is trying to kill you. That part you already knew. It's that our sharpest instruments and our best equations keep coming back with answers that don't match the universe or each other. Every single one of these is still open. Right now, tonight. The people whose whole job is to know, don't know. And the sky just keeps doing it. Quietly, precisely, without the slightest interest in whether we ever catch up.